Hi guys, my name is Bappy and you are welcome to my YouTube channel. So guys, in this video, we'll try to master the Model Context Protocol MCP in detail. So I think you know this MCP is very important, especially in Agentic AI whenever you are developing any kinds of Agentic AI application. This MCP, that means Model Context Protocol, is super important. So we'll try to understand why this model context protocol is super important. We'll also see the practical example of that. We'll try to develop agent system with the help of model context protocol, and we'll try to see the benefit of that. So this is going to be one short video. So in this one short video, guys, we'll try to learn the complete MCP concept. We'll also see the practical development of MCP, each and everything I'm going to clarify. But to start with this video, guys, there is a prerequisite. You have to complete it first of all. Let me show you. So as you can see, there is a project I have developed in my Agentic AI playlist called TripMate AI End-to-End Multi-Agent Planner. Okay. So before you start with this MCP one-shot video, first of all, try to complete this project implementation, because this project I have implemented, this agent I have implemented without using the MCP, right? And there I proven that if you are not using MCP, still you can implement these kinds of project. But after learning this particular MCP concept, you will automatically get to know, okay, why MCP is required, and whenever you are building these kinds of agentic system, why you have to add the MCP there, right? So for this, first of all, try to complete this project, because I'm going to upgrade this project only. The MCP example I'm going to show you as a code, the project wise, I'm going to recreate this project with the help of MCP, right? And if you want to see how to create, how to implement this project without using MCP, that time you just try to watch that, because here I have showed you each and everything, the database setup, okay, everything like the fast API backend setup, each and everything I showed you there. Please try to complete it first of all, then try to start with this video. Okay. Yeah, so this is the requirement only. If you just complete this requirement, I think this one shot video would be very easy for you, and you can understand the entire MCP concept. So I think you remember we implemented this TripMate AI application. So this is a agentic, multi-agentic AI application, and this is the architecture, guys, of this application. There basically we created 4 agents. One is the flight agent, hotel agent, itinerary agents, okay, final response agents, and each of the agents was using some kinds of tools, okay. And these tools, guys, how I have written as a custom function. As you can see, as a custom function, I have written this tool, and here I was using some third-party APIs, okay. I was using some third-party APIs. So with the help of these APIs, I was getting the information, and I was using these things as a tool, right? I was using this thing as a tool. So if you see the architecture, so here you can see. So I was using Aviation Stack API. I was using Tably API, okay, for the real-time source operation. So each and everything I've already clarified in this video, guys. Please try to go ahead with this video if you want to understand, okay, about the MCP, because I'm going to take the example from this project only, okay, so that your understanding would be more clear what exactly this MCP and how it is working and why it is required, okay. So see, without MCP, I have created this project, okay, it's completely fine, it's already working, okay, there is no issue. But if I add the MCP here, okay, if I add the MCP in this kinds of agentic system, right, so what would be the benefit there? We'll try to understand in this video. So guys, before I start the MCP concept, first of all, I want to show you the application we have developed previously, this TripMate AI application. Okay, so this is the multi-agent application we have created, and it is using like some kinds of APIs, okay, some kinds of tools to get these kinds of real-time informations, right? So here you can give any kinds of, let's say, a trip plan. Let's say you want a trip from Bangladesh to Japan. So you want a complete 7 days trip plan, okay, under 2 lakhs taka. So if you are, let's say, sending this message to this platform, and if you click on generate plan, so you will be able to see that it will generate the entire plan. So see guys, this is the entire plan I'm getting. So here we are getting the flight information, we are getting the hotel suggestions, we are getting the day by day itinerary, then we are getting some estimated budgets and final recommendation. So how this information is coming? Because we are using some kinds of real-time APIs here as a tool. So if I show you the code, so here you can see I was using this flight tool. So this is getting the real-time flight informations. Then I was using this Tably tool. It is getting the real-time like hotel informations, okay, then itinerary information. So real-time internet search it was doing, right? So these kinds of actually third-party APIs I was using, okay, and we have used this, and we have created the tools, and we have integrated with our agents, and that's how our agents is working fine, okay. So there is no issue with that. It's completely working fine, okay. So this project I have implemented without MCP, without model context protocol, right? Now let's try to understand what is model context protocol, and if we add this model context protocol, okay, in this kinds of project, so what would be the benefit? Okay, before that, first of all, let's try to understand what is model context protocol exactly. So guys, as you can see on my computer screen, so this is the definition of MCP. MCP stands for Model Context Protocol. As you can see, MCP stands for Model Context Protocol, okay? It acts like a universal USB port. This is important, just try to remember. It acts like a universal USB port, okay? So I think you know about USB port, right? USB-C port, sorry, USB-C port. So what USB-C port does, basically you can connect this USB-C port with all kinds of device, okay? And there you can connect different other port as well, okay? That means this is the universal port for all the devices, okay? That's why we call it this MCP as universal USB-C port for the AI application, okay? Especially for the agentic application. Instead of building custom APIs to link an AI model to GitHub, Google Drive, okay, or let's say Aviation Stack API key, Tably API key, right? Or local databases, developer use MCP to create a standardized link, okay? Now, what this definition means, let's try to understand. So as you can see here, I have shown you one example. The example name is problem without MCP. Okay. So let's say here we have implemented our agentic AI application. Let's say as of now, we are considering we have implemented this TripMate AI. Let's say this is our TripMate AI app. Okay. We have created the application I showed you, right? And this TripMate AI is using some kinds of tools, right? Some kinds of third-party APIs. Let's say it is using weather APIs. It is also using aviation, okay? Aviation stack API. So with the help of that, what we are getting the flight information, right? Real-time flight information. Then it was using this Tably as well, okay? Tably API. So I was using Tably API, okay? Tably search tool. I can also name it as search tool, right? Tably search tool. So with the help of that, I was getting the real-time internet search operation, okay? And just to add some example, I added some other like tool as well. Let's say Google Drive integration, GitHub integration, database integration, then maps integration, flight API integration. Okay, I have added these are the information. But as of now, let's try to consider this is our app, TripMate AI app, and it is using some kinds of tool, okay, to perform the task. Let's say whenever user is giving any kinds of plan, right? User is giving any kinds of plan. So what is happening? Based on the plan, it is trying to get the real-time information by using these are the tools. Okay, let's say it will check the real-time weather information in that location. Let's say you want to visit Japan. First of all, it will check the Japan weather condition. Okay, then it will use aviation stack API key to get the real-time flight informations. Tably for the good hotel informations. Okay, that's how it will get different information. Now, what is happening right now inside our app? So inside our app, these are the functionality I have written as a custom function, right? I have written as a custom function. Custom function I have written. And what is the problem with the custom function? Because in the custom function, I was using some kinds of API, right? Some kinds of API endpoint. Let's say if I show you, so I think I can show you, you'll see this thing. See, this is the base URL. Okay, this is a API, right? This is a API I was using from the aviationstack.com. So let's say if I visit this website, I will open this website. Okay, this is the API, right? I will go to the aviationstack.com. So this is the website, right? And this website gives you this API. So where I will get this API? So there is API documentation. If I visit that, so this is the API documentation, and here they have already written how to use their API key. And as of now, you can see their API version is version 1. Okay, they are using version 1 for this API call, right? So whenever I was using in my code, right, I was using version 1. Okay, so let's say in future they will change this API to version 2. Let's say they have added some other functionality, they have upgraded something in their API and they have named it as version 2. Let's say like that they have named version 2. Okay, version 2. That time what will happen? So if I'm creating the application with the help of version 1 and after 6 months they have changed it to version 2. So that time what will happen? This API URL will not work. That time if you hit this version 1, it will not provide any kinds of real-time flight information because they have changed it with version 2, right? So to fix that, what I have to do, I have to again come to my code. I have to again open this flight tool, my custom function, and there I have to change this URL. Okay, I have to change this URL and I have to do all of the modification is required to call this URL, right? That means I have to change entire code, right, inside my flight tool. And this is not one time. Let's say after 1 year, they have changed another version and they named it as version 3. That time again, you have to open that. Again, you have to change the code. So that's how there is no possibility your application will remain same. Your application will run as same you have created. Let's say you have created right now and it is completely running fine. Okay, but there is no possibility it will run entire life. So there is a chance this API will get changed. Okay, and you have to open your code and you have to modify this code again and again, right? And if this API changing is happening, okay, frequently, so what will happen? Whenever user is using your application, let's say this is the application user is using, and user will use 24/7, right? 24 hours by 7 days, they will be using your app. So let's say by chance, this API changed, right? This API changed and you are not sure about, let's say this API got changed, right? That time user will come, they will give their plan and they will generate the response, but they will not get any kinds of flight information. Okay, that time this part would be completely empty. So that time user will have a bad experience with your app, right? But you are not sure this API changed, right? Let's say you are not aware about this API has been changed. Let's say after 7 days you got to know, okay, this API got changed and user is getting trouble, you are getting bad feedback from your application. That time you will tell your developer to fix that particular part. But that's how things won't work. Okay, whenever you are creating the application, you have to make sure your application would be robust. If anything is getting changed, right, your application should automatically get to know that and it will automatically fix that. This is called healing. Okay, so your application should heal itself. So you are not responsible to fix your application always. The way you have to create the application, it should heal yourself. If anything is getting changed in the API documentation, instead of manually changing this upgrade, instead of manually changing this migration, your application should automatically fix that part so that user won't be getting any kinds of bad experience. Okay, so that's why MCP comes into picture. Okay, that's why MCP comes into picture. So right now, the way I have created this application, it is directly connected with these kinds of API tools, right? If this API tool is getting changed anytime, let's say it is getting version 3, that time definitely this function is not going to work. Okay, that time you will be getting no data here, no data. And if you're getting no data, user will have a bad experience with your app. Okay, but if you are continuously monitoring your application, if you're changing these are the documentation, let's say regular basis, whether they have changed or not, that time it's completely fine. You can still use this application, you can still run this application, there is no issue with that. But let's say in an application you are using thousands of tools, right? Thousands of tools. So is it possible to visit thousands of tool documentation every day and try to check their upgrade? Try to check their migration? Definitely not. This would be very hectic for you, and you don't have that much of time to go through all the documentation, right, one by one. So that is why researcher introduced MCP, Model Context Protocol. Okay, Model Context Protocol helps like let's say developer to prevent these kinds of problem. Okay, now let's try to see how it will help. But before that, let's try to understand another problem. Okay, another problem user will be having, or let's say developer will be having. Let's say whenever you are creating any kinds of agentic system, let's say here I have created TripMate AI, that multi-agent application, right? So this TripMate AI I have created with the help of this LangGraph framework, LangGraph orchestration framework. So apart from LangGraph orchestration framework, there are some other frameworks are also available in the market, like OpenAI is there. With the help of OpenAI SDK, you can create the agent. With the help of Crew AI also you can create the agent. With the help of Agno you can create the agents. With the help of N8N, right, you can create the agent. With the help of Microsoft AutoGen you can create the agent, right? There are multiple frameworks are available. With the help of that you can create the agents. And every time whenever you are creating the agents, you will be using these kinds of tool, whether you are using flight tools, external weather API tools, any kinds of Google Drive API tools, database tool, it doesn't matter, you will be using some kinds of tool. Okay, and for every framework integration you have to write this custom function separately. For LangGraph this custom function would be different. From OpenAI this custom function would be different. For Crew AI this custom function would be different. Okay, that means every framework you have to write this custom function as a different. Let's say in future you want to switch from LangGraph to Crew AI. That time what you have to do, you have to change the entire code. The tools you are using, all the tools code you have to change with respect to the Crew AI. That means again this is very hectic task, right? You have to change the entire code base and it will take lots of time. Okay, so why not, I'll just try to make one connection and automatically this change would be happening. So this basically helps us, this MCP model context protocol. Now let's try to understand how MCP helps us here. So by the diagram itself I think you can see why I told this MCP as a USB-C port, right? So as you can see, just try to consider this is your USB-C port, right? So USB-C port, what is the benefit of USB-C port? You can connect with any device and you can connect multiple devices here. Okay, that means the connection, okay, the connection would be common for all the devices here. So let's say initially I was using this custom API, right? I was using this custom tools or custom API directly to my application. But right now here I'm using some kinds of MCP server. Okay, so what this MCP server? MCP server is a server. Basically it has the tool you need. Let's say here I have shown you one example of the weather MCP server. So see, for all of the API, right? All of the API you will be using, all of the tool you will be using. For all of the API tools, there are some MCP servers are available. Nowadays in internet, you can get any kinds of MCP server. For weather information, you will be get the MCP server. For Google Drive also, you will be get the MCP server. GitHub also MCP servers are available. Database also MCP servers are available, right? From map integration, MCP servers are available. Flight integration, MCP servers are available. Okay, so for all kinds of tools, you have the MCP server. Only what you have to do, you have to use that MCP server. Okay, and this MCP server will automatically connect it to the tool. Okay, the tool it will be using. Let's say to get the weather, what kinds of tool it need? It need get a weather tool, and this tool will be connected to the API, the external API, right? The external API, let's say we are using. Let's say as of now, I'm considering here I'm using Aviation Stack API, Aviation Stack API, right? So Aviation Stack API, what it use? API URL, right? API URL. I think you saw that in aviationstack.com website, there is a URL I was using, right? I was using one URL. So if I'm using this Aviation Stack MCP server, so it is already connected with that tool, that means the API. Okay, so with the help of API, it is fetching the real-time information and it is returning to the agent. Okay, so what it does, basically your MCP server will connect it to the API, and whenever your agent needs any kinds of tool, right, any kinds of information, it will call that MCP server, and MCP server will use that tool and it will give the information, and your agents will try to use that. Okay, that means in future, let's say if your API is getting changed, let's say from version 1 it has changed to version 2, that time it will change here only, right? It will change here only, and automatically MCP will try to heal that. Automatically MCP server will try to fix that. That means this connection won't be changing anymore. This connection won't be changing anymore. Whether you are creating MCP with LangGraph, whether you are creating MCP with OpenAI, whether you are creating AI agents with OpenAI, AI agents with LangGraph, AI agents with Crew AI, it doesn't matter. This connection is not going to change. Okay. So automatically this upgrade, this migration will be updated to the MCP server, because this MCP server we are using some third-party MCP server. We are not creating this MCP server. If there is a way you can create your own MCP server, this is also possible, but most of the time we use third-party MCP server. And third-party MCP server, what is the biggest benefit? If there is any API upgrade, if there is any version update, they will automatically migrate in their server. You don't need to change inside your code. Okay, your application would be connected automatically. Your application will be upgraded to the next update. Okay, so there would be any kinds of downtime. So this is the benefit of using the MCP server. I hope you get it. Now let's go to the next one. Yeah, so let's try to understand this MCP component right now. Okay, but before understanding this MCP component, first of all, I want to clarify one thing. Let's say, hmm, and to clarify one thing, let's say I'll draw one simple application diagram. Let's say here we are we have created this StripMate AI agent, right? StripMate AI agent. So this StripMate AI agent is using some kinds of tool, right? It is using aviation stack tool, Tably tool, right? With the help of tool, it is getting the information and it is using in the agent. But if I'm replacing here with this MCP, let's say instead of this custom tool, if I use the MCP here, okay, let's say if I here I'm using this aviation MCP server, okay, aviation MCP server, and this server is connected with the tool. That means the API, okay, this API. Let me show you this API. This is connected to this API, okay. Now what is happening whenever I'm using this this MCP server and it is continuously using this API, and this API inside this MCP server, it already has the tool, like it has already like this kinds of custom function. Let's say if you want to get the real-time flight information, okay, flight information, so there would be some tool, let's say get flight information, okay, or let's say all flight information, okay. That's how it will have different tools. So whenever your AI agents will go to the MCP server will return some kinds of tool, okay. It will return some kinds of tool, and all the tools are connected with this API. Let's say right now the API version is version 1, okay. So after 6 months this API got changed with, let's say, version 2, okay, version 2. So what is the benefit of using the MCP? That time automatically this migration will be happening to the MCP, because this MCP I'm using, this is a third party MCP. This is available over the internet. This is called remote MCP, right? So this migration will be automatically updated to this MCP, okay, MCP server. So here you don't need to change inside your code. Only you just connected this MCP server with your AI agents. Okay, automatically this upgrade will be available inside your agent also. You don't need to change the code. So the let's say whoever developed this MCP server, this aviation stack MCP server, they will take care of this part. Okay, you don't need to like upgrade inside your code. This is the main benefit here. But in our previous app development, right, inside our previous app development, we are directly connecting this custom function, and if there any upgrade is happening, we have to change it manually. But MCP, here you don't need to change it manually. Automatically server is getting updated and your application is using that particular new upgrade. This is the main benefit here. That's why I have shown this diagram. So this diagram represents that if you're connecting with the MCP server of your any kinds of AI agents we are creating with LangGraph, OpenAI, Crew, it doesn't matter. This connection you don't need to change. Whatever upgrade is happening inside the API or whatever inside the tool, it will automatically upgrade to the MCP server, and all of the application will be working on the upgraded part without any kinds of downtime issue. This is the main benefit. I hope you clear. Now to this to run this MCP, right, for this protocol, that is model context protocol MCP uses some component, okay. So the major component, it has the MCP client and MCP server. So as you can see, let's say we have implemented some agentic application with LangGraph, Crew AI, OpenAI, or Agno, whatever you have created. So all of the agents, right, you are implementing. Let's say here I've created this StripMate AI agents. So this StripMate AI agent should have a MCP client. If you want to use the MCP server, first of all, you have to create a MCP client. So this client is responsible for connecting with the MCP server. That means whatever communication will be happening, let's say you have given a prompt. Let's say I need to plan a trip from Bangladesh to Japan. Now for this, definitely your agent needs to call the flight information. Your agent needs to call the hotel informations with the help of these tools. Now how it will do the communication with the help of this MCP client. So this MCP client will go to the MCP server. It will first of all check how many MCP servers are available, and all of the MCP servers like has the tool or not, all the API integration or not. If it is available, it will automatically understand what kinds of MCP server to use. Let's say here you have given give me flight information. So for this, definitely aviation stack API should be called. Okay. So let's say here I have listed different MCP server. Let's say travel is there, MCP server is there, weather is there, Google Drive is there, database is there. So let's say if I want to get uh, best hotel information, that time what I have to do, I have to use Travely search. With the help of Travely search, I can search the flight, I can search the best hotels, okay, and I can get the informations. And how this selection is happening, because every agent is using a large language model. I think you know that every agent has a large language model, LLM, right? And LLM has the reasoning power. So whenever you are giving the prompt, I need hotel information or flight information, automatically your LLM is deciding which MCP server needs to be called, and how it is calling with the help of this MCP client. That means MCP client is working as a bridge between your MCP server and your agentic application. That's how whenever you are creating your agentic application, MCP client should be created inside that agentic application. Okay, and this MCP will try to communicate with all the MCP server, whether if you want to use any search flight MCP server, whether you want to use any search tool MCP server, search hotel tool MCP server, weather MCP server, Google Drive, database, GitHub, whatever you need, all kinds of servers are available, whether it's remote or whether it's local. You can communicate with the help of this MCP client. That means the major component is MCP client and MCP server, and each of the MCP server is connected with the tool. Okay, different tool. Okay, let's say this travel search MCP server is connected with some external services like flight API, hotel API. This weather MCP server is connected with the weather API. This Google Drive API MCP server is connected with Google Drive API. That means every server having their own API, own tool, right? With the help of this tool, with the help of this API, they're working. Okay, they're working as a tool, right? And if any API upgrade is happening, right? If any API upgrade is happening, so automatically this upgrade is happening inside the MCP server. So that time you don't need to change this connection. You don't need to change this code. This code would be common. Only you just need to connect once, and all of the upgrade, whatever happening in future, it would be available here only. You don't need to change it anytime, right? So this is the main benefit. And to implement this MCP, we have to create this MCP client and we have to add the MCP server. This is the component. Okay, this is the component of MCP. I hope you get it, guys. Okay, very much clear. Now let's try to see some other things. Yeah, I'll try to show this part right now. So as I told you, this model context protocol is having two components. One is the MCP client, and MCP client should be available inside your agentic application. The agentic application you're creating, let's say we are creating the TripMate AI. Let's say this is our entire TripMate AI application. Okay, inside that your MCP client should be available. So you have to create this MCP client, and to create this MCP client, there is a already a functionality available inside LangChain. With the help of LangChain, you can create this MCP client. Okay, and this client would be connected to different MCP servers. So if you want to use any API, real-time weather informations, or let's say flight informations, you can use the MCP server. If you want to use any database, you can use the MCP server. If you want to access any local file, you can use the MCP server. If you want to use the Google Drive, you can use the MCP server. For GitHub, operating system, internal company system, everywhere this MCP servers is available. Okay, so either you can use the remote MCP server. Okay, I'll tell you about the remote MCP server. Either you can use the local MCP server. Even you can also create your custom MCP server. Okay, everything is possible. Okay, we'll try to see everything one by one. Now, that means in a high level view, your AI application is having the MCP client, and MCP client is connected with different MCP server. So wherever it requires any kinds of MCP server, it will be using that because it has the large language model. And whenever user is giving any kinds of input, based on the input your LLM is understanding, let's say user is asking, tell me the weather in Delhi, right? So your LLM is understanding, okay, it is asking for the weather. Now let's say here you have the list of the MCP server. Let's say you have Google Drive. Okay, you have Google Drive, you have weather MCP server. Now which one to use? User is asking what is the weather in Delhi. So that time your LLM should know, okay, it has to use the weather MCP server. And weather MCP server is connected with different tool like get weather information, get current weather, okay, get humidity, get temperature, this kinds of thing. And automatically your LLM will decide which tool to use. And this tool is connected with API, right? To get the real-time information, weather information, it has to hit a API. So this API connection is already available, right? So that's how the entire system is working. Now let's try to see this thing in a more detailed way. So see, let's say this is your AI app. It has the MCP client, right? And it is connected with some MCP server. Let's say as of now, I have showed you the Google Drive MCP server. Let's say user is asking, uh, upload this file to the Google Drive. So that time it will use the Google Drive MCP server, and Google Drive MCP server has some tool connection. As you can see, these are the tool. So it has find files tool. Let's say in Google Drive we can find the files. In Google Drive we can list folder items. In Google Drive we can read files. In Google Drive we can upload files. In Google Drive we can create any kinds of folder. Okay, these are the tools, let's say Google Drive is having. And what is the purpose of that? For searching file, list content a folder, read a file content, upload file, create folder. Okay, for these are the purpose we use this tool. And this tools is connected to the API of the Google Drive. So with the help of this API call, it is using, right? It is working, right? And if Google Drive is changing their API, let's say from version 1 to version 2, okay, version 2, that time it is changing inside the MCP server. That means this connection you don't need to change. Your application connection will remain same. You don't need to change inside the code. Automatically this upgrade would be happening to the server only, right? So this is the main benefit. That means whenever you are using the MCP, MCP client is going to the MCP server. MCP server is listing all the tools it has, and it is automatically selecting which tool to use. Let's say you want to upload any file. That time, instead of using these are the tool, it will only use this upload file tool that time, because user needs to upload any file. Let's say you want to only read the file or download the file. That time this will use this read file tool. Okay, instead of using list folder file items, upload, okay, it will use read file tool that time. Let's say you want to create a folder. So create the folder, this tool should be used, okay, instead of uploading, reading. Okay, these are the things. So that's how the entire MCP works. Okay, I hope you get it. Now see, this thing I have showed you in a more detailed way. Let's say this is your AI Agentic AI app. It has the MCP client inside that, and it has some multiple MCP server. Let's say it has Google Drive MCP server. It has weather MCP server. Okay, and all of the server is connected with different tools. Okay, let's say Google MCP server has their tool for listing files, reading file, creating files, update file, delete file, search file. It has the tool. Okay, and all the tools are using API. I think you know that with the help of API, this is working. For weather also, it has some tool. Like say weather MCP server, it has get current weather, get weather forecast, get air quality, get temperature. And how it is getting this information? With the help of API. It is using some kinds of API. Let's say you have another tool here, another server here, which is aviation stack. So MCP server. And it has also some tool. Let's say get flight information. And how getting the flight information with the help of API. Okay, so I think you are getting right how these things are working. Now every API has their version, like version 1, version 2, right? I already showed you in the documentation. Let's say it is using version 1. It is also using version 1. It is also using version 1. So there is a possibility. Definitely this company will change this version, right? If they're doing any major upgrade, let's say it has changed to version 2. That time it's not necessary to change your code inside your AI app, right? Because you have connected with the MCP server, and MCP server is connected with the MCP client. So whatever upgrade will be happening inside the server only. Okay, automatically this upgrade will be happening inside the server, and MCP client will try to get to know that okay, there is a change has been done. So you don't need to change inside your AI app. That means there should not be any kinds of downtime of your application. User will not any kinds of bad experience. Okay, because continuously your data will be coming up, because MCP is handling this kinds of part, right? So that's why we call it as a MCP as a USB-C port. Okay, it is once you have connected with the app, you don't need to take care about the other things. Okay, automatically this will take care everything. I hope you get it. So yeah, here I have shown you another example. Let's say this is your AI app, and it has the MCP client, and it is connected with multiple MCP server, and every MCP server is using some kinds of tools, right? And all the tools are using some kinds of API call, as you can see, right? So let's say user has given one input. What is the weather in Delhi today? Will it rain tomorrow in Mumbai? Let's say this is the input. Okay, so what is happening? Because your AI app using your agentic app using a large language model, right? And large language model has the reasoning power. So whenever this input will come to the AI app, your LLM will decide which MCP server to use. Okay, whether it has to use the Google Drive MCP server, whether it has to use the weather MCP server. So user is asking about the weather, so definitely it will tell the MCP client to communicate with the weather MCP server. First of all, uh, this MCP client will tell how many server you have. Okay, so this will return, okay, I have Google Drive server, I have weather MCP server. Then MCP client will return that to the LLM. Now LLM will try to tell that, okay, now try to use this weather MCP server. Now again client will go to the weather MCP server and will tell how many tools you have. Okay, so to get the weather information. Now let's say this weather MCP server will return these are the tool. I have get current weather, I have get weather forecast, I have get air quality, I have get temperature. But what is the user question? What is the weather in New Delhi? That time definitely this get current weather tool should be used. Okay, that time all the tools it will return, right? All the tools it will return where? To the MCP client. MCP client will return to the LLM, right? LLM. Now LLM will decide, okay, now it has to use get current weather. Now it will tell the MCP client to use get current weather tool. Now again MCP client will tell MCP server to use get current weather tool to get the real time weather information. Now it will hit that API, right? It has the API connection, right? With the help of API it will get the real time information. Then this real time information will again return to the MCP client. MCP client will return to the LLM. LLM will use that information to generate the final response. That's how the entire communication is working, and this is called model context protocol. The protocol it is happening, right? From client to server, server to client. This is called protocol. I'll tell you this protocol more about that. Okay, so for this protocol it use a method. Okay, I'll tell you about this method. So I think you got to know how this system is working. Okay, fine. Now see, I told you about the protocol, right? So basically your MCP uses this JSON RPC protocol. Okay, JSON RPC format to communicate with the MCP server. So let's see, if user is asking any kinds of input, first of all, what is happening? LLM is deciding which let's say server to use. MCP client is sending that request. How? With the help of JSON RPC 2.0 message. That means it will have this kinds of JSON, okay, JSON structure. So let's say user is asking about sorry, here this is the let's say input. What is the weather in Delhi today? Will it rain tomorrow in Mumbai? So this, let's say this message would be converted like that. So this is the message. So city name Delhi, and this is a tool call, and it has to get the weather information. So this will go to where? This will go to the weather server, weather MCP server, and whether a server is having some kinds of tool, some kinds of, let's say, tool integration. What kinds of tool? This kinds of tool. So which tool to use? Get weather, current weather. So it will use that tool and it will hit this API. It will get the response. Okay, that means the current weather information, and again it will return to the server, and server how it will try to make the format with the help of this JSON RPC. That means again a JSON file would be created, and there this temperature condition, okay, these are the real-time information would be sent where? To the client again. Okay, and client will send to the LLM. LLM will try to use that, and it will give you the final output. Okay, so that's how with the help of this JSON RPC 2.0 message format, this entire communication is happening. Okay, I hope you clear. Now let's try to see some types of MCP servers are available. I told you there are some types of MCP servers are available. The first one is local MCP server. That means you can create the servers inside your local machine, inside your same computer. While you are running your agent, right? In the same computer, you can create the server. If this server is not available in remote, sometimes it's happened, right? Let's say you are creating MCP, you want to use a MCP, right? Let's say you want to access your private folder. Let's say there is a folder inside your computer, you want to access that. So definitely for that, you don't have any remote MCP server. That time you have to create your local MCP server, custom MCP server. Okay, so that time we call it as a local MCP server. So your AI app will use MCP client. So everywhere MCP client would be available. Without MCP client, you won't be able to communicate with the server. Okay, and to communicate with the local server, we use this as STDO communication method. Okay, so this is called actually transport, or means communication method. So to communicate with local MCP server, we will be using this standard IO, input output. Okay, standard input output. The full form of this STDIO is standard input output. This communication method we'll be using. With the help of that, we'll be communicate with our MCP servers. Okay, and there is another one called remote MCP server. So let's say your agentic AI having this MCP client, it is using some kinds of communication method called streamable HTTP. Okay, so all of the internet MCP server are available, like Google Drive, right? This Google Drive. Then I showed you some other things, right? Here, Google Drive, weather, okay, database. So these are the actually remote MCP server. Okay, these are the remote MCP server. And to communicate with this remote MCP server, we'll be using a streamable HTTP method. Okay, basically this will be using to communicate with the MCP server. Now, what is local MCP server? You can see a local MCP server runs on the same machine where your AI application is running. So let's say this is your AI application, you have the MCP client and it is communicate with the local MCP server. Let's say you have local file system MCP server, Git MCP server. Okay, let's say Git usually we install inside your local, right? Git MCP server, Postgres SQL MCP server. Let's say we have pgadmin, Postgres SQL we have already installed, right, inside a local machine. If you want to communicate with that, you have to use this MCP server at that time. And all of the communication would be happening with the help of this standard IO. Okay, SDT IO communication. And what is the remote MCP server? As you can see, a remote MCP server runs on another machine on internet. That means, let's say this is your laptop. You have created your Agentic AI application. This has the MCP client. And with the help of internet, you are communicating with some kinds of server. Let's say weather MCP server, Google Drive. Okay, so this is called remote MCP server. You are using some server. It is running on other computer, other let's say remote server. Okay, we know that we call it as a remote server. Someone has created this server and it is running and we are communicating with that. This is called remote MCP server. Okay, and the communication we use called streamable HTTP. Okay, then we have another MCP server called custom MCP server. So an MCP server that you create yourself. Let's say you don't want to use local MCP or remote MCP. You want to create your custom MCP server. This is also possible. Let's say you have a secret company database, and to communicate with that from your AI agents, that time either you can't create the local MCP, either you can't create the remote MCP. That time you can create your custom MCP server. Okay, so this is called custom. So the MCP allows you to use local, remote as well as the custom. Okay, everything you can do, and all of the example we'll try to see inside our practical project. Now let's try to understand what is this STDIO. That means I told you there are some communication type, STDIO and streamable HTTP. So first of all, let's try to understand about the what is STDIO. The full form of this STDIO is standard input, standard output. Let's say you have the application, your Agentic AI application. It is having this MCP client, and the communication it is doing the MCP server. For this, it is using STD, standard output and standard input. So this is only for the local MCP server. This is the way local MCP client and local MCP server communicates. Local MCP client and local MCP server exchange JSON RPC message through a standard in and standard output. Okay. Now there is another one called streamable HTTP. So let's say this is your Agentic AI app. It has the MCP client and it is communicating with this MCP server. That means whatever running on the cloud with the help of the HTTP request. It's obvious, right? If I want to access any other website, I have to use the HTTP communication there because it is running on cloud. That's why it is using HTTP streamable communication type. You can see streamable HTTP is one of the transport mechanism used by MCP client and MCP server to communicate over a network. They exchange JSON RPC message through HTTP request. The message client sends MCP request over HTTP, and streamable HTTP used when the MCP server runs in the cloud. Okay, I hope you clear. Now you can see MCP has the two concepts. That means the message format. The message format I already told you about the JSON RPC and the transport type. Okay, transport type means this basically this communicates in a two method. One is the standard IO and one is the streamable HTTP. Okay, and everywhere it uses this JSON RPC format. Okay, so yeah, that's how guys the entire MCP works, and this is called the MCP. And if you're using the MCP, what should be the benefit? Each and everything I have clarified, okay, from this video. I hope there won't be any kinds of doubt right now why this MCP is required whenever you are implementing these kinds of AI agents, right? And without MCP also we can create the AI agent, but what would be the biggest challenge there, right? To maintain the entire application lifetime. But if you're using MCP, you don't need to take care this thing lifetime. Automatically this part will be healing itself, right? This is the biggest benefit. And especially in AI agents application, we'll be using tool. Okay, there is no compromise. Tool we have to use. Okay, like as much as tool you will be using inside your AI app, your application would be more powerful. That's why whenever you are using this tool, right, tool concept inside your AI app, that time MCP comes into picture. But if you are not using the tool, that time you don't need to use this MCP. Whenever you are using any third-party tools, use the MCP. Okay, instead of writing the custom function, use the MCP. So this will save your life. Okay, and everywhere nowadays, if you see any agentic application, they're using MCP. Get it? So yes, this is all about from this video, and I have already clarified about the model context protocol. Now there are some MCP servers are available. Let me show you. So if you come to Google and search for all list of all MCP servers, okay, so there are some website, they will show you the all kinds of MCP servers. Okay, see, if you see here, all kinds of MCP servers are available. See, for Brave Search, Everart, GitHub, GitLab, Google Drive, Google Maps, Postgres, okay, Redis. See, all kinds of MCP servers are available. I think some other website is also there. Browse all MCP servers. Here you can see all kinds of MCP servers are available. What kinds of tools and software you have used so far, right? Everything is available. Let's say you want to use let's say MongoDB. I think for MongoDB also it has the MCP server. MongoDB. Just search that. See, MongoDB has the MCP server. If you want to connect with the MongoDB database, it has the MCP server. Let's say you have to communicate with the Google Drive. See, Google Drive MCP servers is available. If you want to communicate with the Google Map, if you want to use the Google Map tool, right, inside your Agentic AI, see, Google Map is also there. If you want to communicate with the flight, okay, for flight also, it has different MCP server you can use. Get it? So that's how you can check this MCP market website, and it has all the MCP guideline, how to use that and all. Okay, they have written each and everything. You can refer that. Even they have already given the code how to use their MCP server. Each and everything they have given, you can check that. So in this video, what I'm going to do, guys, I'm going to show you how we can develop this model context protocol. Okay, how we can utilize this model context protocol inside our AI agents development, and we'll try to upgrade this particular agent itself. Okay, so if you see the architecture of this project, so this is the project architecture, guys. I think I already explained in that video. I think if you have already gone through this video, I think you saw this architecture, right? So here I created actually 4 agents. One is the flight agents, then hotel agents, itinerary agents, then final response agents. Okay, and each of the agent was connected with some kinds of tools. Okay, and these tools, guys, I had written custom function. If you have seen that, this is my code. Let me show you. This is my code. So in the tool section, you can see that I have written custom function here. Okay, and what should be the issue with this custom function? This part I have already explained in that model context protocol video. So now, instead of using these kinds of custom function, what I'm going to do, guys, I'm going to use something called model context protocol, MCP. Okay, MCP servers. So this part we'll try to learn, and this is the updated architecture, guys, we'll try to implement in this video. So as you can see, this architecture, this project will try to implement with the help of model context protocol right now. So again, my architecture will remain same, only some slight update I have done. So as you can see, flight agents should be there, hotel agents should be there. One new agent I'll try to add inside this development, which is weather agents. Okay, so basically I want to also know whenever I'm planning for any kinds of trip. Let's say I'm planning the trip let's say from Bangladesh to Japan. So I want to know the Japan weather condition. Let's say if I visit Japan, so what would be the weather condition? Should I take my umbrella out there, or should I, let's say, take my sunscreen out there? Okay, so this part I have to know. So how I can get to know? With the help of this weather agents. Okay, weather agents will try to fetch the real-time weather informations, and will try to get the informations as well, right? So here again we'll try to use the model context protocol. Then our itinerary agents would be there, then final response agent should be there. And now we can see each of the agents should be connected with the MCP server. Okay, there are local MCP servers are available and remote MCP servers are available. Okay, so both I'm going to show you how we can integrate inside the development. So I'm going to show you how we can add the remote MCP server. Even I'm also going to show you how we can add the local MCP server. Okay, even I'm also going to show you how we can add the custom MCP server. Let's say you don't have any kinds of MCP server, but you want to create your own MCP server. This is also possible. This part I'm going to show you. Okay, so in this single implementation, I'm going to cover up all of the MCP servers. Okay, whatever I have explained in my previous video. That means I'm going to cover my local MCP server, remote MCP servers, as well as the local MCP servers, remote MCP servers, and custom MCP servers. Okay, these three part I'm going to cover. And after that, all of these database integration, I think you remember, I also integrated Postgres SQL database. Okay, I already set up this database in my render cloud. As you can see, this database is already running Postgres SQL. I think you can see it is just behind my screen. Let me show you. See, here is the Postgres SQL server it is running. And I already showed you how we can set up this Postgres SQL server in this video. So make sure you complete and just prepare this project. Okay, even in this video I have also showed you how to set up this Postgres and the PG admin. Okay, so if you want to see the database and everything, see all of our message log, each and everything are available for the memory. So we are connecting with the Postgres server which is running on the render, and we are able to see with the help of PG admin. Okay, so each and everything I have clarified in this video. And this is the code of this project, guys. This is already available in the video description. Okay, so in this video description is already available, so make sure you clone this code and try to set up inside your system. Okay, so I'm going to utilize the same code, and there I'm going to do the upgrade of my MCP code as well. Okay, and this project I'm also tracing in my Langsmith platform. As you can see, TripMate AI. So I was continuously tracing all of the execution, all of the threads, so each and every things you can monitor here. Okay, so yeah, lots of things we had integrated inside this development. So yeah, I'll try to continue with this one. So yes, this is the entire architecture, guys. We'll try to implement inside this video. So make sure you watch till the end. So first of all, let's open up my code. So I'll open up my code. So this is the code. This is my previous project code, the TripMate AI multi-agent system. So here, what I'm going to do, I'm going to just add the MCP, that means model context protocol. So first of all, what I can do, I can create a file here. I'm going to name it as MCP client. Okay, MCP client test.py. Let's create a file. So here, basically, first of all, we'll do some experiment. And once this experiment is working fine, I will try to add inside our final development. Okay, first of all, let's try to see how we can create the MCP client and how we can add the MCP servers there. So if you have already seen my previous video, so there I already told you MCP has two major components. Okay, one is the MCP client and another one is MCP servers. Okay, let me show you. Yeah, so here you can see, so here I already moved all of my Excalibur files. Okay, whatever diagram I have created, it is available inside my Excalibur files folder. Okay, I created this folder, and inside that I kept all of this file. And if you want to open it up, you have to use one extension called Excalibur. Okay, inside your VS Code, just try to install. After that, you will be able to open this file. So as you can see, this is the actually components I already discussed in my previous video. That means MCP is having two major components. One is the MCP client and MCP servers. So if you're creating your AI agents application, inside that, first of all, you have to define the MCP client. And in this MCP client, you have to connect this MCP servers. Okay, that means MCP client will try to communicate with the MCP servers and will try to reach this data to the AI agents. Okay, so this is the bridge between your MCP servers and as well as your AI agents. Okay, so first of all, we have to create this MCP client. So for this, we created this file called MCP client.test. MCP client underscore test. And here I'm going to write code related MCP client. But before that, you have to install some of the library. So let me open up my requirement.txt. So this is the requirement.txt. So here I'm going to add some additional library I need for this development. So this three library I need. Okay. So these three library I need. One is the LangChain MCP adapters. So with the help of this LangChain MCP adapters, we create the MCP client. So as you can see, this is the MCP client, right? So to create this MCP client, we'll be using this LangChain MCP adapters. So LangChain has already predefined MCP client. Okay, you can use that and you can define the MCP client. Then you have to use something called nest async IO. Okay, so why this is required? Because already if you see my app.py, right? If you see my app.py, we are already using this asynchronous programming. Okay, and I told you why this asynchronous programming is required, because here we have created multiple actually route, right? And it's not like that we'll try to wait for another route to be executed, right? So everything should be running in a asynchronous way. That means we are executing in parallel. Okay, and this is required whenever you are creating the AI agents, because AI agents needs so many things to run, right? And if you are running sequentially, so there would be lots of, let's say, time buffering. That means you have to wait for another execution, then your next execution would be happening. So I don't want that. Okay, that's why I'm using asynchronous programming. And this asynchronous programming also I have already taught you in my playlist. Okay, if you can go through that playlist, you'll be able to understand why it is required. So already we are using asynchronous programming inside our fast API development, backend development. But again, whenever I want to implement this MCP, right, model context protocol, it's recommended to use the asynchronous programming. Okay, why? So here you can see why we have to use this asynchronous programming inside MCP. As you can see in MCP, that means model context protocol code, we use asynchronous programming, async await, to prevent long running tasks from freezing the server and blocking the AI agents. Okay, that means MCP servers handle input output heavy operations. Okay, and the standard synchronous code would force the LLM to wait completely idle for one task to finish, okay, before it could do anything else. So using asyncs allows the servers to remain highly responsive and process multiple instruction concurrently. Okay, that means in parallel. So that's why we have to use this asynchronous programming in model context protocol development as well. Okay, so it is super important, guys. If you are not using asynchronous programming, you can't create the MCP client or servers. Okay, this is very much required. You have to use that. So that's why you can see inside my backend development, I was using this asynchronous programming, right, inside fast API. And whenever we'll try to create this MCP client as well and MCP servers, we have to use this asynchronous programming. That means we will be using 2 times, right? So if you are using this asynchronous programming, there would be something called event loops, right, for the asynchronous calls. So now we are using asynchronous into 2 time, right? One is the backend.py, another one is the MCP server development. So there would be nested event loop. Okay, so one event loop would be available inside your backend.py, that means your app.py, right? And another event loop would be available inside your MCP development. Okay, that means 2 event loop would be available, and whenever you want to run the nested event loop, okay, that time you have to use this nest async IO. Okay, this particular package. So this allows us to handle nested event loops. Okay, if you are using, let's say, thousands event loop, it doesn't matter if you're using this particular library. So this will handle this part. Okay, and if you're not using this library, there would be some kinds of error, okay, for the nested event loops. That's why we'll be using this particular library. And the last library I need, which is MCP, that is model context protocol. So if you want to, I already told you I'll be creating our custom like MCP, right? And to create the custom MCP, I will be using this MCP. Okay, MCP library. With the help of MCP library, we can create our custom MCP servers as well. Okay, so that's why I need this. These are the library for this development. Okay, I hope you get it. So for this, you have to install that. So let's open up my terminal. Let me stop my application, and I'll be installing this requirement.txt. So for this, let's write pip install -r requirement.txt, and make sure you activated your environment. Okay, so I think you remember I created this travel environment for this particular project. So I'm installing this library inside my travel environment. So if I now execute this command, see, requirement is already satisfied for me, because initially I already installed these are the package. That's why it's available, but for you it will install. Okay, so once you have done that, now we can implement our MCP client, as well as we can integrate the MCP servers here, okay? And we can test whether everything is working or not. If everything is working, we'll just try to integrate inside our development, okay? First of all, I'm going to show you how we can add the remote MCP servers. And for this, I'm going to use actually this one, Tabily, okay? As you can see, Tabily, we'll try to use this Tabily MCP. This is a remote MCP servers. And if you can search on Google, like Tabily MCP servers, okay? So official Tabily website is having their documentation, Tabily MCP servers. If I open it up, and I already told you, almost all kinds of MCP servers are available, whatever you need. So if you want to know more about like how many MCP servers are available, simply just write list of all MCP servers. There is one website called I think this one. This one. So here you will see all kinds of MCP servers are available. Even you can also search here what kinds of MCP servers you need. See here, MCP market. So here you can search what kinds of MCP servers you need. So GitHub MCP servers is available. Okay, Taskmaster is available. Cogni is available. Then Serena is available. Okay, that's why we are having different MCP servers. Okay, whatever you need, just try to use it from here. So here I'm going to use this Tabily MCP server, and how to use Tabily MCP servers, they have already written inside their documentation. So simply just write like Tabily MCP servers. You will see this documentation, and they have already given the guide. If you want to use this MCP server in Claude, how to use that. If you want to use this MCP server inside your cursor, how to do that. Okay, all the steps they have given. Okay, but here we'll try to use this API functionality. So they have one API functionality. There is one URL. Okay, if you want to use this, their remote MCP server, this is the URL you have to use. Okay, so we'll be using this URL, and you have to provide the API key, Tabily API key. And if you hit this URL, right, you will be getting the servers. And for this, they have already given some kinds of commands. See, this is the commands they have given. Okay, so these are the commands we have to use. And if you are using these commands, automatically your server would be connected. Okay, and main benefit is that if there is any change in their API, Tabily will upgrade inside their servers. Okay, and it will automatically reflect inside your project. Okay, you don't need to change that. This is the main benefit. So yeah, let's try to use that. So let's open up our code editor, and inside this MCP test, first of all, let's import some library. Like I need operating system, I need this async IO, right? Because I have to use asynchronous programming inside MCP development. This is required. Then I need certify. Why you need certify? I think you remembered there is a path issue you'll be having in the Windows machine. So to prevent that, you have to use this certify library as well. Then you have to use this .env to load the environment variable. And we'll be importing this MCP client from LangChain MCP adapters. So from LangChain MCP adapters, okay, inside that there is a class called client, right? And from the client itself, I'm going to import multi server MCP client. Okay, there is a function called multi server MCP client. So this thing we'll be using to create the MCP client. Okay, let me close these are the file as of now. So we're creating this particular client. Now to prevent the path issue, we have to use this line of code, this SSL cert file and request CA bundles. Okay, we have to use this certify.while. Then we have to load the environment variable. So load environment variable. After that, we'll be loading all the API key. Okay, one by one. So first of all, I need the Tabily API key. So I think remember we have the Tabily API key already. So this is the Tabily API key. So let's load that. So Tabily API key. Then I need to load the aviation stack API key. Okay, so let's load all the API key, whatever I need as of now. Or here I'm only going to show you the Tabily demo, right? So for this, I think Tabily is fine. I'm only going to load the Tabily. But apart from that, you need two more actually API key, which is one you need this open weather. Okay, open weather API key. And anything you need, let me just check. Table is there, aviation stack is there. No, only one API key you need, which is open weather API key. Okay, because I told you here we'll be creating another new agent called weather agents. Okay, and this need this weather API key. Okay, if you want to create this server, right, for this you need the API key. So this MCP, I'm going to show you how to create the custom MCP. Okay, for this, and to create this I need the weather forecasting API key. Okay, so this thing will try to collect, and there is a website called Open Weather. Okay, I'm going to use that. So as of now, let's do it with the Tably. Later on I'm going to show you, okay, how to do that part as well. So yeah, I think we have loaded the Tably API key. Now next thing we have to create the client. Now let's create the client. So client is equal to multi-server MCP client. Inside that you have to give your MCP servers. Okay, see, this is the format, so make sure you are giving the same format you given this curly bracket. Now inside that you will try to mention all of your server. Okay, list of the server. So the first servers I need to add the Tably remote server. Okay, that means this server, Tably remote MCP servers, and for this we are using this Tably documentation, and they're telling you have to use this kinds of command. Okay, so this is actually MCP configuration. You have to use this configuration. Okay, so I've already created this configuration. Let me show you. So that's how your configuration should look like. As you can see, this is the configuration. So first of all, you just try to give the name of the server. So this is the name, Tably. Okay, even you can also change this name if you want, but I have given Tably. And you have to mention the transport type. Okay, so I think remember inside my here whenever I explain about the model context protocol, right? So there I told you, see, we have two kinds of MCP server. One is the local MCP server, and it use STDIO transport type. That means to communicate with the MCP server, it use this STDIO, okay, communication. And for remote servers, it use something called streamable HTTP. Okay, so right now we are implementing this remote MCP servers, and for this we'll be using streamable HTTP transport. So that's why inside this transport like key, we are mentioning streamable HTTP. Okay, because this is a remote MCP servers. Okay, and what should be the URL? So this is the URL, and make sure you are copying the same URL from the Tably documentation. So this is the URL, as you can see, this is the URL. Just try to copy and mention it here. Okay, and here in this part only just try to mention the API key. The API key we are getting it from here. Okay, that's it. So if you just write this line of code, that means you have successfully connected one MCP servers with your MCP client. Okay, that much simple it is. Okay, now let me test whether it's working or not. So what I'm going to do, so here I'm going to write a function. This function basically return all the tools you have with your MCP client right now. Okay, so right now you can see this MCP client, the MCP client we have created, it has only one MCP server, which is Tably. So it should return Tably, and Tably having some tool. Okay, so this MCP server is connected with some kinds of tool. What is the tool? Tool means nothing but it's some kinds of function. Let's say what Tably does, it does the internet search operation, then it's give you real-time data. Okay, so these are the function it is having, and how it is extracting these are the information with the help of this API key. That means to implement one MCP servers, first of all you need to create the MCP client, right? MCP client you have to create, then you have to create the MCP servers. Okay, then inside MCP servers you will be having tools. Okay, different tools, and to implement these tools you need API. Okay, so this 4 step we usually follow to create one MCP development inside any kinds of AI agents. Okay, yeah. So now let me create that function, and make sure whenever you are creating the function, you are using this asynchronous programming, okay? Because without asynchronous programming, this will not work. So I'll be using async def. I'm going to name it as get all tools. Okay, get all tools. Now simply I'm going to write tools. Tools is equal to await. So if you're using async, you have to also use await. I think you remember I already taught you this asynchronous programming inside my playlist. Please try to check. It is already available inside my playlist. As you can see here, I already explained about this asynchronous programming. Okay, this is required. So that's why I'm using this await, and we are using this client. And there is a function you have to called get tools. Okay, if you just call this function, it will basically list down all of the servers as well as the tools, okay, with respect to their tools. Now after getting it, I'm simply going to print all of the MCP tools as well as their name. So yeah, this is the code. So here I'm printing available MCP tools, and we are running a for loop. So for tool in tools, okay, and we are printing all of the tool names. Okay, simple. Now let me test whether it's working or not. So for this, what I can do, I can open up this test file, test.py, and previously I written some code. So what I can do, maybe I can remove this line as of now. Okay, so previously, see, I was using this direct tools, okay, direct tools, and I was adding inside my agents, but right now we'll be creating the MCP servers for that. See, previously for the tably search operation, I created this function, right? I created this function, custom function. And if you give any query, so this will basically do the internet search operation, and this will give you the real-time answer. But right now I don't want to use that. Okay, I want to use this MCP servers I have here. It is already connected with the remote MCP servers, right, for the tably, and it is already having all kinds of tool you need for the real-time search operation. Okay, this is what we'll try to connect. So that's why I'm going to remove this code, and here I'm going to just write, first of all, I'm going to import async IO. Then I'm going to import from MCP client test. Okay, import get all tools. That means this this function I'm importing. Then after that, here I'm going to write if underscore name and is equal to underscore main, and inside that you have to just write async io dot run get all tools. Okay, so if you're using asynchronous programming, you have to run that event loop with the help of this async io dot run. Okay, so this is called event loop, and here this is the function we want to call. So this is not a simple function right now, this is asynchronous function. That's why to run this asynchronous function, you have to use this async io dot run. Okay, now if I execute this code, now you'll be able to see all the tools would be listed down. Now if I just simply write python test.py, okay, see, available MCP tools, tably search, tably extract, tably call, tably map, tably research. Okay, so here I don't need all of these tools, only I need tably search. Okay, if I want to do the real-time search operation, I need this tably search tool. And what is this tool? This is nothing but a custom function. Okay, this kinds of custom function they have written. This is nothing but this kinds of custom function they have written. Okay, but this is exposing as a tool in the MCP server, remote MCP server. This is the beauty, right? And to perform this search operation, okay, in the custom function, they're using the API key. Okay, that's how things are working. I hope you get it. So right now, successfully, you have connected with one MCP server, which is tably, and it is having some kinds of tool we have already listed down. Okay, now here I'm going to write another function. So this function, what it will do, basically it will try to return only the tably search tool, because here I'm having multiple tools. Okay, but I don't need multiple tools. I only need tably search tool. Okay, for this I need to write another function. So here what I can do, let me show you. Yeah, so here I'm going to write another function. Yeah, so this is the function I have already written. Let me show you. This is the function. So this function returns the tably search tool object. So as you can see, first of all, I have taken a variable here. And initially the value is none, and this is the function async def get tably search tool, and I'm making it as a global variable. And first of all, I'm checking if this tably search tool is not none. Okay, if it is not none, that means there is something, right? That time I'm just doing the returning operation. I'm just returning from this function. But if it is none, what I'm doing, first of all, I'm going through the client and I'm getting all the tools. Okay, then I'm looping through all the tools, and here we are doing the condition operation. That means here we are doing the generator. We are applying the generator function. I think you know, right? In Python we have something called generator function, and there we apply something called next, right? So here it will give you all the tools. So I'm doing next, and once this is matching, like if tool name is equal to tably search, that time I'm just storing this tably search wire inside my tably search tool. That means here. Okay, this is a very simple function I have written. So basically here I am having multiple tools, but I don't need all the tools. I only need tably search tool. So these tools I'm just extracting from my all the tools, and I'm storing inside this variable. Okay, so once we have these tools, simply what I'm going to do, I'm going to return it, right? I'm going to return it. So for this, maybe I can create another function. So with the help of this function, we can do the real-time search operation. So this function name is async def tably MCP search, and this takes a query. Let's say user is given, tell me about the last match of FIFA World Cup. Okay, so this query will come here. First of all, I'm calling this function get tably search tool. Okay, and what it does, it will return you the tools, right? What tools? Tably search tool. Okay, where it will return in this variable tably search tool. Here basically this tool would be saved, and we are using this variable, and we are doing the AI invoke operation. That means this is a tool object right now, and the tool object I can do the AI invoke operation. I think you know that, right? We are again awaiting the response because we are using asynchronous programming, and here we are passing the query. Okay, now it will do the real-time search operation. It will give you the result, and this result I'm returning. Now let me test whether it's working or not. So I'm going to come inside my test.py, and here I'm going to import this function tably MCP search. Okay, tably MCP search. So here what I can do, simply I can call this tably MCP search. Just a minute. And here you have to pass a query, right? Yeah. So tably MCP search, and let's prepare a query here. Latest news about AI. Okay, so this query I'm going to pass inside my tably MCP search. Okay, this function. Now see, it will return you all the latest news. Now clear, and let's execute test.py. See all the MCP tools. Okay, now it is not giving you anything, because if you see here, it is returning the result, but I have to print that, right? So as of now, just to get it, what I can do, maybe I can print the result here. Okay, print the result here just to show you. Print result. Okay, now let me execute it again. See, here is the response we are getting, and it is using different website, as you can see, and it is giving you all the latest news in AI. Okay, that means it's working perfectly. Okay, now we are not using this custom tool as of now. See, we are not using this custom tool. We are using the MCP right now. Okay, we are using the MCP, and from the MCP servers, we are getting the tools, list of the tools, and we're utilizing this tably search tool, and we're doing this kinds of real-time search operation. I hope you clear. Okay, so this is the experiment idea I wanted to give you, like how things are working, how we can create the client, how we can add the servers inside that. Okay, and how we can utilize that. Okay, now simply you can use this function inside your code. Okay, inside your backend file. Now let me show you how to integrate inside backend file. So as of now, what I can do, instead of printing, maybe I can return the result. Okay, because right now I want to use it inside my app. That's why instead of printing, I want to return the result. Okay, now here what I'm going to do, I'm going to open up my backend.py. Okay, so inside backend.py, I think you remember I was importing this tools, tably certs. Okay, so initially I was using this tably certs here inside my hotel agents. Okay, hotel agents need the tably certs, right, to find the best hotel inside location, right? So here I was using this custom function, but right now I don't want to use this custom function. I'll be using my MCP servers. So for this, simply I'm going to comment this code. I'm not going to delete, guys. I'm going to comment just to show you the changes I'm doing. Okay, so here I'm just I'll just do the comment, and let me show you how to add that. So after that, let's yeah, so you have to import MCP from MCP client test, from MCP client underscore test import. You have to import this function, this tably MCP search, right? So once you have import, now you have to go to your hotel agent where you are using your tably search, right? So here in the hotel agents, I'm using the tably MCP search. So instead of this, right now, what I have to do, I have to write this code. Let me show you. Yeah, so I have to write this code. Let me comment this line and add this line. Okay, so again you have to import this async IO. So let me import. I'm going to import it here. Import async IO. Okay, so with the help of async IO, you have to execute that function here. So async IO dot run tably MCP, and whatever query you are getting from the user, you are passing it inside the function, right? And this will give you the result, and this result you are returning to the agents. Yeah, that's it. And you don't need to change inside your app.py because app.py is already updated, right? Here we are only invoking the route. So only you just need to change inside your backend.py, because inside backend we are creating all the agents, right? Now this agent is using MCP. Okay, it is connected with the MCP. So this architecture we have developed right now. See, these hotel agents we had, right? So previously I was using the tably custom function, right? But right now we have connected with the tably MCP tool, which is a remote tool. Remote MCP server, right? And this MCP server is having some kinds of tool, and we're using tably search tool only. And this tably search tool is using tably API key to get the response. Okay, I hope you get it. That means this connection we have done. Now the benefit would be, if there is any change in the API, okay, tably will try to upgrade in their server. Okay, and it is automatically reflect inside your agents. That means you don't need to change this code. This code you don't need to change anymore. Okay, this code you need to change anymore. Automatically tably will take care of this part, and your MCP client will load that. This is the beauty of MCP. Okay, I hope you get it. Now let me test whether it's working or not. So right now this tably tool is not required. You can also delete, but I will keep it just for your reference. Okay, or I think you can delete it as well, because this is not required, right? So what I can do, I can delete this tably tool. This function I can delete. Or let's keep it. Okay, just for your reference, I'm keeping it here so that you can refer, okay, where I have done the change. So I'll keep it. Now let me test whether it's working or not. So close it. This is my client and this is my backend. We have already added this tably search MCP. Now let's execute my app.py. So I'm going to open up my terminal, clear. So python app.py. It should work. Let's see. Running. I'll open up my localhost port number 8000. This is running. Now let me give a plan a complete 7 days Japan trip from Bangladesh, including flights, hotels, and sightseeing under 2 lakhs. Now generate the plan. Okay, I told you one issue you'll be getting if you're not using this nested async IO library, right? Because right now there is two event loop is running, right? That's why you can see async IO dot run cannot be called from a running event loop. Okay, that means one event loop is already running here, right? Inside my app.py, we're using already async bonus programming. So if you want to run the multiple event loop, so you have to use that library. So this part I forget to add. Let me show you. So there is a library we already installed, right? I think remember, called nest async.io. This is called nested async.io. Okay. So I'll try to add inside my app.py. So I'll open up my app.py, and here you have to add this line. You have to add this line of code. That's it. Okay. So this allows nested event loops for async call in fast API. Okay. So we are importing this nest async.io, and we're just calling apply function nest async.io dot apply. Okay. If you do it, it will handle the multi event loop like right now. Okay. So yeah, let me save and let me re-execute the code again. Running. So I'll open up, refresh. Now let me give this plan again and generate the plan. So see guys, perfectly it's working. As you can see, this is the trip summary, this is the flight information, and this is the hotel suggestions. Okay, now this hotel suggestion is coming from the MCP servers. Okay, this is not a custom function anymore. Congratulations guys, you have successfully created your first MCP servers. Okay, you have connected your first MCP servers with your client. And this is by day by day itinerary and estimated budget and final recommendation. Okay, amazing. Our first experiment is done and it is working fine. Okay, so like that we'll try to add our next things, which is the flight MCP, right? That means the aviation stack MCP. So that means to get the flight information, previously I was using this custom function, right? Inside the tool I was using this flight tool, and this is the big custom function I have written, and there I was using this aviation stack API key, right? Here I was using aviation stack API key and I was hitting this URL, right? And this is the entire function I have written. But right now we'll try to convert as a MCP server and we'll be using the tool from that, right? So this part I'll try to add, and for this we'll be using local MCP. Okay, so see, this aviation stack doesn't have any remote MCP server. Okay, so like I used this Stabily one, right? This aviation stack doesn't have any remote MCP servers. It has the local MCP server. Someone has this created already. This is available inside a GitHub. Let me show you. So this is the GitHub. This is the GitHub. This GitHub is from this user. So this is aviation stack MCP. Okay, and this MCP he has created for the local. Okay, local machine. This is not running on remote. Okay, so we have to set up everything in the local, right? So here they have given already the MCP server configuration. So we'll try to use this configuration without cloning this repository. Okay, this configuration we'll try to use for that. But if you want to clone this repo, okay, and set up, for this you have to use this configuration. There you have to give manual path directory, but I don't want that. I will be using this one. Okay, this one would be more easy to use because here I don't need to set up their GitHub repository. Okay, so this thing will try to run in the local. Okay, that means with the standard IO communication we'll try to do. Okay, let me show you how to add that as well. So right now, instead of writing inside my MCP client tests, what I can do, maybe I can create a final file here. I'm going to name it as MCP underscore client. Okay, .py. And here, what I'm going to do, I'm going to copy my previous code. I'm going to copy my previous code. So right now, I'm going to load two API key. One is for Tably API key, one is for aviation stack API key. Okay, because right now I want to add this flight information as well. For this I need aviation stack API key. Okay, so I'm loading all of the API key, and here I'm going to copy my server, sorry, client. client, and inside it we have the server, right? Let's copy this code, and to get the tools, this is the function I have written. This will return all the tools available. And right now what I have done, let me show you. I have written a single function. Okay, instead of writing multiple function, I have written a simple single function. So previously, I think remember, I written a single function to get the tably search tool, right? So this was actually searching like whether it has the tably search or not. Then it was returning. So what I can do right now, I can also I will be also using aviation stack, right? Aviation stack like MCP servers, and I told you we'll be creating the local MCP servers. Okay, and from here we'll try to get these servers from this GitHub repo. So you just need to copy this code. Okay, copy this code. I think till here you have to copy. Okay, so make sure you are copying till here. Okay, and you mention after your first server. Okay, make sure you give a comma. After that, just try to mention the next server. Okay, make next server. Now if you want, you can also change this name. You can change the name. I can name it as aviation stack MCP. Okay, and here you have to add another parameter, which is transport. So right now this transport should be stdio. Okay, studio. Why? Because this is local MCP server. Okay, and to communicate with the local MCP server, I have to use this stdio, standard output, input and output. Okay, this transport type. And command, they're executing UVX command to get their see what will happen if you add this line, right? If you add this configuration, it will automatically get this GitHub, right? And in this GitHub, they have already written the code related this aviation stack, right? Like how to get the flight information. So, okay, for every let's say operation, they are having their custom function. Okay, like previously written, right? Yeah, previously written here. So these kinds of function they have also written, okay, inside their code, okay, inside this GitHub repo. But they have exposed these are the function as a MCP tool right now. Okay, so their tool I want to use. That's why I'll be using their configuration. So if you're using MCP, right, you have to always use this configuration. With help of this configuration, you can get any kinds of remote as well as the local MCP servers. For custom one, definitely you have to create your own custom function, but for remote and local, you have to use this configuration. Okay, I think you get it. So basically, it will get this aviation stack MCP GitHub repo. See, this is the name of the GitHub, aviation stack hyphen MCP. So we're giving the same name here. Okay, it will get the GitHub repo, and it needs the API key, aviation stack API key, and here we have to pass the API key right now. Here we'll be passing our API key. The API key we're loading. Okay, that's it. So if you just add this line of code, this line of configuration, now it will load the aviation stack MCP. It will load all of the tools it has, and you can use that tool. Okay, now let me show you whether it is connected successfully or not. So maybe I can call this get tools, and I can see whether my aviation stack tool is available or not. So again, I'll try to open my test.py. Instead of calling this, I can call my get tools again. Clear Python test.py. Okay, one error I'm getting, which is a coroutine was expected. Let me check, guys, what is the problem. Oh, okay. The problem is that still I'm executing my this one uh, MCP client test, right? But I have to execute this MCP client because everything is available inside my MCP client.py, right? From this file. So here I have to change that. So instead of writing this, I can comment and write from MCP client import get all tools. And here I have to give this parenthesis. Now it should work. Let's see. See, available MCP tools. First of all, definitely we had the tably. Okay. Now see, these are the your flight tools as well from the aviation stack. As you can see, flight with airlines, historical flight by dates, flight arrival departure schedule, future flight arrival and departure schedule, random aircraft type, random airplane details information, random countries detail information, random cities information, list airport, list airlines, list route, and list taxis. Okay, so these are the custom tools they are having. These are the custom functions they have written in their GitHub. Okay, in their GitHub. If you check their GitHub, these are the custom functions they have written. Okay, see, if you say check their server, these are the custom function they have written. Okay, and we are able to get this as a tool. They have exposed these are the function as a tool. Right now I can use this function as a tool. Okay, so from here, what are the tools I'm going to use, guys? Okay, what are the tools I need to use? I need to use this get this airports as well as the airlines. Okay, I think if I get these two information, I think this is enough for us. Okay, for our agents. Again, let me check whether this is fine or not. Yeah, so I only need list airports as well as the list airlines. Okay, these two tools I need. First of all, I will get all the airports, I'll get all the airlines, because for my travel agents, okay, I need to see the airports as well as the airlines. Okay, for one country to another country, these are the information I need. But if you want to use any other function, you can use that, okay, as a tool. So for this, what I can do, maybe I can write a final function. Instead of writing multiple function, I can write a single function here. Yeah, so this is the function I have written. Okay, Tably and aviation tool. So this function returns the aviation tools as well as the Tably tools. Okay, Tably tools, and this is the same function I have written previously. Whatever I written inside my MCP client test, as you can see, this is the function, but this is like more detailed one. Basically, it returns two things. One is the aviation tools as well as the Tably search tool, but it was only returning the Tably search tool. Okay, so as you can see, first of all, we are making this two variable as global. Then I'm checking search tool is not none. Okay, and aviation is not none. If it is not none, we are returning. Otherwise, we are looping through the tool. Okay, and first of all, we are upgrading the Tably search tool. Okay, I need only the Tably search tool. Then for the aviation, okay, instead of Tably search, whatever tools are available for the aviation stack, right? For this list airport, list airline, okay, whatever I have, I'm storing inside this dictionary. Okay, because this is a dictionary I have taken, right? And once I am able to save these are the tools as a dictionary, now I can use any of them. Okay, either you, if you want to use the list airlines, either if you want to use the list airports, you can use any of them. Okay, that's why I'm storing inside the dictionary. Now for the Tably MCP search, this is the same function I have just copy pasted. This one, okay, this one I've just copy pasted here. So it takes the query and it returns the uh, real-time uh, updated data from the internet. Okay, and for the aviation stack, this is the function we'll be using. So I have written async def aviation MCP call. Here, first of all, you have to give the tool name. Okay, tool name. So what is happening? See, right now in this dictionary there would be all the tool name, right? All the tool name for the aviation stack. But you have to tell which tool you have to use. Let's say I want to use list airports and list airlines. I'll just give the name here. I'll just give the name here. So what it will do automatically, it will list down all the tools. Then again, it will loop through that, okay? And it will match whether this tools is matching with the user tools name or not. If it is matching, okay, we are storing inside our variable and we are doing the AI invoke operation and we are returning it. Okay, very simple. So basically this will filters which tool user should use from all the aviation stack, whatever tools you are having. Okay, this is the idea. And this is already connected with the MCP server, with my MCP client. So this MCP client is getting the server, and in this server we are having all the tools, and all the tools are using the aviation stack API key. That's how things are working. Now let me show you how to integrate inside our application. So for this, again, what I can do, I can open up my backend.py. So here I'm going to first of all import. See, right now this flight tools, search flight tools is not required from my tools because initially I was loading it manually from my function. So right now I'm going to comment this line as well. Okay, this is not required. So here I'm going to import everything. So instead of importing from my MCP client test, I'm going to import from my MCP client only because MCP client should be my final file. Okay, inside that we have already written the tably MCP search. So let's write my other things as well. So let's import my aviation MCP call. That means this function, aviation MCP call. Okay, this aviation MCP call basically will return whatever tools you need. So here I'm going to import it here. Aviation MCP call. So after that, let's upgrade inside my code. So this aviation, where I need to add inside my flight agent. Okay, let's go to the flight agent. Okay, so here is my flight agent. Yeah. So see what I'm going to do. I'm going to just upgrade this flight agent with more detail instead of just simply returning the information. So right now, what I want to add a large language model. Okay, so this large language model will try to get these are the informations. That means my flight information. So I already have the tools, list airport and list airlines. Okay, I'll give these informations to my LLM, and I'll try to ask my LLM to generate some informations like departure time, okay, arrival time, then route, typical flight duration, estimated flight budget. Okay, so these are the information I'm going to generate from my large language model by providing these are the information. Okay, so what I can do, I can maybe comment this function, the function I've created. So let's comment this. And let's add my new function here. So let me show you my new function. So this is the new function I have created, guys. Very simple. Only I have added a large language model. See, first of all, I am preparing a prompt, flight agent prompt. So here I'm telling you are a travel flight expert. User will give the query, right? Take the query as well as take the airport information like airport data as well as the airlines data. That means we'll try to give airport data as well as the airlines data from my tool, right? And you have to generate likely departure airport, likely arrival airport, airline serving this route, then typical flight duration, estimated airfare, okay, range or budget, then peak session pricing warning, booking advance. Okay, so these are the things I want to generate. So for this I have written this function called flight agent, and this should be a actually a node, right? We are using LangGraph and this should be a node, and for this we are passing my state, travel state, and already we have prepared this travel state, I think you remember, right? And we have this flight result variable there. So here, yeah, where is that? So we are passing this travel state, then we are printing the information like we are inside now flight agent right now. Then we're taking the user query and we are doing that MCP call. Okay, so we are again using async IO run aviation MCP call. Okay, we are calling this function. Okay, and this function takes tool name. Okay, which tool to use. Okay, it takes the tool name, like which tool you want to use. So I want to use list airport. That means these tools, list airports. Okay, so automatically it will return that list airport tools, and we are doing the invoke operation, AI invoke operation, and it is giving you all of the airport list. Okay, inside this variable. And second, I'm invoking my list airlines tools. Okay, this one, list airline tools, and again we are giving this name list airlines. We are invoking. Okay, because inside this function we are invoking, I think, remember. So here we're doing the AI invoke. Okay, and we are getting all of the informations. All of the informations we are storing inside this variable. Then we are printing those information inside terminal just to see whether we are getting the information or not. Then after that we are preparing the prompt. Okay, so previously we created the prompt template. Okay, this is the prompt template. Now we are formatting the prompt here. So prompt flight agent prompt dot format. We are giving the query, user query, airport data, and airlines data. Instead of giving all the data, I'm giving that many of word. Okay, that many of information. So this is kinds of word limitation we are giving just to show you, because if I'm passing all the informations, there are lots of airport airlines informations are available. So again, what will happen, my token limit would be increased, and I am using free model, right? This grok model, llama model, I think you remember, right? We are using grok provider. So my free limit would be over. That's why, just to prevent the limit, I am passing some information, just passing some airport information. Okay, instead of all the airport informations. But if you are creating the actual agents, okay, for the production grade, that time just delete this line. Okay, make sure you delete this line. Okay, you can take all of the airport and airlines informations. Then after that we are using the large language model. Which large language model? Our same large language model we have initialized here, this llama 3.3 model. Okay, versatile model. We are invoking this model right here. Then we are giving the system prompt. You are a expert travel flight planner. We are giving the prompt. Then it is giving you the response. We are taking this flight data variable. We are storing the response, and we are returning it as a flight result. Okay, inside my state. Okay, same thing, only I just added a large language model call here. So this is the same function. See, same thing. We are returning the flight data only, but initially I was getting the flight data from my custom function and I was directly returning. But right now I'm using a large language model, and I'm using these are the informations to generate some more information, so that my agents can have a good amount of information to give you the idea about the flight information. Okay, so previously the flight information was slightly, let's say, low level, I mean high level, right? Like it was only giving you some flight name and so on. But right now it will give you the flight budget, flight location, each and everything it will provide you because of this function. Okay, so these are the upgrade I have done. So successfully we have added this connection as well. That means in my flight agent we have successfully added my aviation stack MCP servers, and this is local MCP servers. Okay, this is not a remote MCP servers, because here we are not using any kinds of URL. Okay, we are cloning a GitHub repo, and this GitHub repo it will set in your local. Okay, it will start in your local and will try to communicate with the tool. Okay, for this we have added this line of configuration, this configuration. Okay, and transport is equal to stdio. But if you're using remote, it should be using streamable HTTP. Okay, but whenever you are creating your AI agents, make sure you are using all the server as a remote server. If you're using remote server, definitely there is a benefit. Okay, because it is running remote, and everything you are using from remote. Okay, you don't need to set up everything in manually, right? So try to use all the remote server. But if you don't have remote server, in case that time you can use local MCP server. But let's say if you don't have the local MCP server as well, if you want to create your own custom MCP server, this is also possible. This part I will also show you in my next next update. Okay, next update means after this demo, after testing this, I'll try to add inside my code. Okay, that weather one I'll try to create my custom MCP server. Okay, so I think this is done. We have successfully added our flight agent. We have upgraded the flight agent with the MCP. Now let me test, okay, whether it's working or not. Now I'll clear. Again, run my app.py. running. I'll go to my app, refresh. Okay, now let me give this plan and generate the response. Even you can see the terminal. So as you can see, guys, it is able to get all the airports data, okay, as well as the airlines data. Okay, as you can see, all the airlines, all the airports, and these are my MCP tools. And see, we are using list. We are using this list airport and list airlines. Okay, for this we are getting this information. And see, this is my final response. I'm getting trip summary, flight information. Now just try to check this flight information and try to compare with your previous version of the project. Okay, previous version I was only using a single function. There it was giving as a high level, but right now it is giving you the detailed information of the flight, like this departure airport, okay, Dhaka, arrival airport Tokyo, airlines, which airlines you have to take, flight duration, approximate, like how many hours it may take, estimated aircraft budget, okay, how much budget you have to give, booking in advance, okay, how to book in advance, everything it is giving you as a detailed information. This is more good, better version than your previous one. Okay, I hope you get it. This is the hotel suggestion, this is the day by itinerary and estimated budgets and final recommendation. Okay, so yeah, so everything is working fine. Only what I can do in the UI, I can maybe upgrade, because this looks like my previous project. Okay, so maybe I can upgrade in my UI. So I'll open up my index.html, and here a multi-agents travel planner with line graph and MCP. Okay, so let's try to add this line. Sorry. Now if I come here, refresh, now yeah, it looks good. Right now I have added this MCP so that I can differentiate. Okay, this is my MCP version. Okay, and this was a previous one, my without MCP version. Okay, so everything is fine, everything is working, we are good to go. Now next part, we'll try to upgrade. Flight agent is complete, hotel agent is also complete. Now let's try to add this new agents, okay, which is my weather agents. Okay, and itinerary agents is already there. We have to only upgrade this weather agents there, and flight agents also already there. We have to upgrade this weather agents there. Okay, and we'll try to combine all the agents together. We'll try to again create the graph. Okay, we'll try to compile the graph and our agents would be ready. So now last part, we have to add this weather agents. Okay, and for weather agents we'll be using weather MCP server. Okay, and here we'll try to create our custom MCP server. Right now I'll show you how to create the custom MCP server. We have already seen how to create the remote MCP server, how to use the local MCP server. Now let's see how to use the custom MCP server. Okay, all of the server I'll try to cover. Okay, so to create the custom MCP servers, guys, what I can do, maybe I can create a new file here. I'm going to name it as custom weather MCP server .py. Okay, inside that we'll just write the code. So first of all, let's import some necessary library. I'm going to import from MCP servers fast MCP import fast MCP. Okay, so this is the like a Python library we use to create the MCP server, and we already installed inside my requirement.txt this MCP. Okay, so with the help of that, we'll try to create our custom MCP server. Then I need request library to perform the API call. So import request as well. Okay, and request is already installed here. I think I remember what is already installed here. Then I need to import the operating system as well. Import OS. Okay, then I also need to import the environment variable. So let's load the environment variable. Now let's define the MCP object. So MCP is equal to fast MCP. Inside that you have to give the name. So this is my weather MCP server. Okay, so I don't need to give the port. It's fine, weather MCP server. Okay, now I have to collect one API key. Okay, so to get the weather information, as you can see, to get the weather information, I will be using this platform called Open Weather. Okay, Open Weather API key. Just try to search like Open Weather API key in Google. There is a website called Open Weather. Just try to open it up. And there is an option called Get API key. Just click here. First of all, make sure you create an account. Okay, if you don't have account, just try to create one account. So I already have the account. I'll just try to fill the information. Okay, login successful. Now I'll go to the API section, get API key, API key. Okay, now this is my API key. Okay, so I already collected this API key, already created, but if you don't have, just try to generate API key, give the name and generate the API key. Okay, I already created some API key. So don't use my API key, guys. I'm going to remove after this recording. So let me add my API key inside my environment. So this is my Open Weather API key. Okay, this is my Open Weather API key. Now I have to also load it. So here I'll try to load this API key. Okay, Open Weather API key. Because I'll be creating my custom server, right? To create the custom server, first of all, I'll be using my custom function. Okay, inside the custom function, I'll do the API call. So with the help of API call, I'll get the real-time weather informations. Okay, and this function I'm going to expose as an MCP tool. This is the idea, right? Yeah. So see, I already written a function. Let me show you. This is a simple Python function I have written. So if you give any city name, so this will return you the forecast. Sorry, the current weather. So if you give any city name in this function, it will give you the current weather. How it is giving you the current weather? Here we are calling this API. Okay, so this is the Open Weather API, right? We are calling this API. We are giving the parameter like city, the API key, as well as the metrics. Then we are sending the request with the help of request library. It is giving you some kinds of response. We're getting the response. First of all, it's checking whether this response it is not equal 200 or not. If it is not equal to 200, we are returning the data, whatever data we have. Otherwise, we are returning the these are the informations, like we are returning city name, temperature, feels like, okay, humidity, condition, wind speed. These are the information we are returning. So this is a simple custom Python function I have written. Now one question would be in your mind. So here we are using our custom MCP, right? Custom MCP. We are creating our custom MCP servers, custom MCP tools, right? So if there is any API change, then what I have to do? So definitely if you're creating as a custom, right? If you are the author, so definitely you have to take care of this part. Let's say in future, Open Weather, if they change this API version with 2.5 to 3, that time you have to upgrade inside your code. Okay. And you can also deploy this MCP servers in the remote cloud. Okay. You can also make it available for the public. Like we use Tably one, it is available in public, right? You can also expose your MCP server in public. Okay, public can use your MCP server. It is also possible. Okay, but right now we are running inside our local. But as of now, whenever you will be creating your own MCP server, make sure you will try to host that as well. Hosting is also super easy. Maybe in other video I'm going to show you how to host that MCP server. This part is also very simple. Okay, now see, this is not the MCP tool right now. If you want to make this function as a MCP tool, if you want to expose this function as a MCP tool, you have to use this decorator only. MCP dot tools. Okay, if you just write this decorator, now this is not a simple Python function right now. This becomes a MCP tool. Now it is exposed as MCP tool. Okay, you can use it from MCP server right now, MCP client right now. Okay, amazing. So like that, I'm going to create another function called get forecast. Okay, again, if you give the city name, it will hit that URL. It will get the response, and I'm getting the forecast data. Like we are getting the dead time, temperature, weather information. We are getting the forecast. Okay, so this two function I have created. Again, I'm going to expose as a MCP tool. Okay, that's it. Now this is my custom MCP server we have created, right? Custom MCP server we have created. Now I have to run this server. Okay, so right now it is not running in my remote, right? It is not running in any cloud. It should be running inside my local. And how to run in local? For this, you have to execute this line. Okay, mcp.run. So it will run inside your local. Automatically it will take this std IO transport type. Okay, and whenever I will use it inside my client, that time I have to also mention that, right? Okay, as a configuration. Now let me show you how to mention as a configuration. See, we have created this file, and this is my custom MCP server right now for the weather information. Now let's update inside my MCP client. So now I'll open up my MCP client, and here let's load my open weather API key as well. Okay, and here I'm going to add my configuration. Let me show you. So that's how you have to add the configuration. So again, I'll give a comma, and this is my third MCP server I have added called weather. Transport type stdio, because this is a local. Okay, this is a local one. Okay, this is a local one. It is running on local. Then command. See, this is the Python file, right? The MCP server we have created. This is a Python file. So to execute this Python file, I need a Python client, right? And where I have this Python client is available inside my environment. Okay, let me show you. By default, if you create your Anaconda environment, so it would be available inside your local C drive. So here I have installed my Anaconda. I'll go to my Anaconda. There is a option called environment. I'll go to the environment, and this travel environment I created for this project. Okay, I'll go inside that. Now here you have a Python client. See this python.exe file. Okay, so this client location you have to give. Just try to copy this location and paste it here. Make sure you are giving your location, not my location, guys. Okay, everyone location would be different. So just try to find where you have installed your environment. Just try to give this location here. Make sure you are giving the same location and mention the R, because this is a Windows path. That's why it's using backward slash. That's why I'm giving the R. Okay. So this is the command. So with the help of this Python client, it will execute this file. And what should be the file location? You have to mention inside the arguments. Okay. So this is the file location. Where it is available? So let me show you. This is available inside my project. This is my project environment, right? So this is the file I have created. Just try to copy this location, the entire location. Okay. This is available in my DSwithBappy coding YouTube. Okay. This is the folder. So this folder location I have given here, as you can see, and we are mentioning the file name. Okay, again we are given the R because this is a Windows path. So these two things you have to only change if you are using my code. Make sure you are using your location, okay, not my location. And here you have to pass your open weather API key. That's it. Okay, now this becomes your server right now. This will automatically connect with your server because this server would be running in your local. We have already executed in the local, as you can see, mcp.run. Okay, and we have already mentioned the type, transport type stdio, because this is running on local. Okay, that's it. Now what I'm going to do, guys, simply, okay, I'm getting some error. Let me check the error. Okay, there should be another bracket. I think I missed out on bracket. Now I think it's fine. Okay, now you can check. This is the format. Okay, so make sure you check the format. Format should be exact like that. Okay, yeah. So yeah, we have successfully added our MCP server inside my client. Now let's upgrade in the code. So first of all, I'll write some function related that weather tools. Okay, I'll just write the function related weather tools. So these are the function I have prepared for the weather tools. As you can see, I have taken two variable, weather tools and forecast tools. Okay, because I have written two function. One is for forecast, one is for weather. Okay, so these two information I'm going to save inside two variable. So this is my function name, initialize weather tools. We are making it as a global. First of all, you're checking this tool is empty. This variable is empty or not. If you're empty, I'm returning. Otherwise, I'm getting the tool. Okay, then I'm getting my get current weather tool. Okay, let me show you how many tools you have inside inside your server. So here I only have two tools. One is the get weather and the get forecast. Okay, so let me list down. First of all, let me show you. So let's say I'll delete this code. First of all, let me show you. Then I'm going to show this code. This is the abbreviation, right? This one I have to delete. I have to delete. So let's open up my test.py. This is already connected with my MCP client and get tools. Okay, now let me list down all the tools. clear python test.py. See, we have tably, we have flight, okay, we have, see, weather, get current weather and get forecast. That means this two function, okay, this two function you can see, and this two function right now, it's a MCP tool right now, okay, we are exposing as a tool, that's why it is listing as a tool inside your server. Okay, that's how we can make our any kinds of custom MCP server, and we can expose all the function as a tool. Okay, anything, just try to think what are the things you need. If you don't find the remote one, you can add this custom one that time. Okay, and you can expose any kinds of function as a MCP tool. This is possible. Okay, so yeah, everything is available now. Simply we can add um, inside my client. Now let me get back to my previous code. Yeah, so yeah, this is the function I have written. So basically this is getting my weather tools. It is updating in the weather tools. Okay, get weather, and this is upgrading my forecast tools. Okay, get forecast tool. That means these tools I'm extracting from all the tools out there. Okay, and upgrading inside this variable. And once we have upgrade inside the variable, so here I have written another function called weather MCP servers, and it is initializing this function, and this function upgrading this actually variable. And here we are giving, user is giving the city name, and it is doing the invoke operation. Okay, so it will invoke the weather tool, okay, weather information, and this function will invoke the forecast tool. That means the forecast information. That means this function. Okay, one will invoke this function, another one will invoke this function. Okay, so this is what we are doing here. That's why I've written multiple function, and we're using async await. Okay, because this should be running as a asynchronous way. Okay, in parallel. So it will not wait, let's say, for another tool to be complete. It will run all the tool in parallel. This is the idea behind this asynchronous programming. Okay, yeah. Now one more thing. See, user here, if I show you my app, so user is giving the prompt like that: plan a complete 7 days Japan trip from Bangladesh. Okay, so user is giving prompt like that, but from here I have to automatically extract the city name. Okay, let's say the country name. Okay, so how will you get the country name? So for this, I'll create a function here, and there I'll be using a large language model. With the help of large language model, I'll automatically extract the city name from the user query. Okay, so here let me show you a destination extractor. Okay, I'm going to name it as a destination extractor. So this is the function. So here I've given the prompt: exact only the destination city or country user whatever query user is giving, and return only the name. Okay, so here we'll do in the llm.invoke operation. So let's use a LLM here. So I'm going to import the same large language model from Grok. So from LangChain underscore Grok, import chat Grok, and here I'm going to initialize the large language model here. Okay, and make sure you also import the Grok API key. Yeah, we are using Llama 3.3 7 billion versatile model here. Okay, so yeah, simply this code I have to add, and now let me check everything is fine or not. Yeah, everything is fine. Now I'll use this destination extractor to extract the country name or city name, whatever user is giving, and I'll just try to return to my forecast. Okay, forecast and weather MCP. Now let's try to add inside my code. I'll open up my backend.py. So I'll import it first of all. Let's import. First of all, I will import my extract destination, forecast MCP search, and weather MCP search. Okay, that means this is the extract destination, forecast, okay, as well as the weather MCP. Okay, all of these things we are importing here. So after that, we'll try to upgrade inside our code. Yeah, so now let me go below. Yeah, now this should be my new agent, okay, which is weather agent. and where I have to add after the hotel agents. Okay, so let's go to the hotel agent. Flight agent, hotel agent. Okay, after hotel agent, I'll try to add my weather agent. So I already created the weather agent. Let me show you. So this is my weather agent, guys. Okay, weather agent, and I'm again giving the state. Okay, state I'm passing, and we are calling this extract destination. First of all, whatever user is giving the query, I'm extracting the city name or country name, whatever user is giving with the help of this extractor. Okay, after that we are calling the weather MCP search. First of all, that means this tool first of all. Okay, then we are getting the weather data, then we are calling the forecast, that means this tool. Okay, and we are getting the forecast data. Then we are preparing this message, weather result and the current weather. We are passing the weather and the forecast, and we are returning it. Okay, and we also need to upgrade this weather result variable. Okay, inside my state, let me show you. If I go to my state, see there is no weather state variable. So let me add that as well. Weather result. Okay, I'm going to name it as weather result. Okay, this should be a string type. Now if I go below, now this weather result would be upgraded. Okay, that's it. Now we have added our new agent. Now we have to also change this itinerary agent because it has the user query, flight agent, hotel agent information. What about the weather agent? I have to also add that. Let me add it. So here after hotel agent, I'm going to add this weather result as well. Okay, whatever weather result I'm getting from here, I'm going to add it here. Okay, now let me check if anything I need to change or not. No, I think everything is fine. Now next I have to upgrade my final response agent. Okay, inside final response also I'll try to add the weather information after hotel. Okay, see weather, we are giving the state weather result, and we are also changing the prompt. So I'll also upgrade this format. See, this is the upgrade. So here I have added this weather information. Okay, this weather information I have created, but previous format it was missing the weather information. Okay, now it will give you trip summary, flight information, hotel suggestion, weather information, day by day itinerary, estimated budget, and final recommendation. And there we're giving some important messages as well. Yeah, so I think everything is fine till here. Now we'll have to build the graph. Okay, now in graph also we have to add this weather agents. Now let me show you. Okay, now let's update our graph. This is the updated graph. So only the things I have added, which is this weather agent. Okay, and we have done the connection here. Yeah, so I think everything is fine. All the database configuration, connection, everything I showed you in my previous implementation. That means this TripMate AI. In this video, I clarified each and everything. Okay, so make sure you complete this video. Okay, even you have the PG admin, right? If you want to see the database, right, you can use this PG admin to see the database. Even I also showed you how to set up the PG admin, how to connect with your remote Postgres server, which we have already installed inside our render. So I think where's the render? Yeah, so here it is running. Okay, so each and everything I have clarified. Please go through this video, guys. Okay. Now let's open it up. Okay, so everything is fine. Now only the change I have to do. This compilation I don't need to change. Yeah, so here I have to give this weather result. After hotel result, I have to pass this weather result. This should be a string. Then at last I'm going to return my weather result as well after hotel. Okay, weather result, and this will return you the weather result. Yeah, so I think this is the update we have to do. Now I think everything is fine. Let me check again. My client is ready. My backend is also ready. We have upgraded this weather agent. Now let's execute my app.py and let me test, okay, whether it's working or not. So I'm going to clear the terminal and let's execute python app.py. It's running. Now I'm going to reload my application. Yeah. Now let me test, guys, whether it's working or not. So let's say I'll give the same plan. Now let's generate. Now let's see the output. Even you can see the execution in the terminal. Now it is inside flight agent. It is getting the flight information. Now see, these are the flight information, airports and airlines with the help of the MCP tool we are getting. And we are having, these are the MCP tools. Okay. So yes, guys, I got the plan. As you can see, this is the trip summary. This is the flight informations, all of the flight information, as you can see, with estimated budget and everything. Then hotel suggestions, and the new sector we have added this weather informations, okay, with our weather agent. That means this agent, okay, this agent is working right now. Now this is the weather right now in Japan. Even they are breaking down the weather condition, okay, day by day. And this is your itinerary plan, estimated budget, and final recommendation. Okay, now let me try with another one. Let's say Dubai. I want to go to Dubai from Dhaka. Let me generate another plan. And this application is running completely with the help of MCP. Now we are not using any kinds of custom function here. Okay, everything we are running with the MCP connection. Yeah, so see, all of this information we are getting, the flight information, then hotel suggestions, weather informations, day by day itinerary, estimated budget, and final recommendation. Okay, if you want, you can download. Even you can also copy that. Yeah. So yes, guys, we have completed this architecture. We have completed our multi-agent system with the help of MCP. Now I think you can understand, you can use MCP with your any kinds of AI agents development. Okay. And I already told you why MCP is required, why agent needs the MCP, what is the advantage to use the MCP. Each and everything I have clarified. Even I also showed you how to create the remote MCP server, how to do the local MCP server. Even I showed you how to create the custom MCP server as well. Okay, each and everything I have clarified. So yes, guys, if you found my content useful, please try to subscribe to my channel and please try to share this with your friends and family. I just need your support, guys. If you support me, definitely I can bring this kinds of content more in future. Okay, so please try to help me to get 100k subscriber as soon as possible. So I have lots of plan, not only Agentic AI. I'm planning for so many content, so many new content, especially the project development. Okay, there are so many projects I'll bring up in this channel, okay, with different tools and technologies. I think you will love a lot. Okay, already I'm getting a very good feedback from you guys. So I want to thank you for that, because if you just like my content, so this is biggest motivation to me, and with that motivation, guys, I can bring lots of content in future. Okay, but definitely I need your support to grow my channel, so that this channel would be recognized by all over the world. Okay, people can get to know, okay, so these kinds of channels is available, and this kinds of content is also available in this channel. Okay, so yes, guys, this is a detailed explanation I have done on this MCP and the practical development of MCP. Okay, now I think everything is clear. Even if you see the Langsmith, so in Langsmith also this tracing is happening. So let me show you. So TripMate AI, you can see all of the execution. And initially we got one error, guys. I think remember that multi-event loop error. Okay, so this error got also logged. Now you can go to the threads. Even you can see all of the threads. Okay, whatever messes we have done so far. So yes, that's how, guys, we have implemented this entire project. And all of these codes, all of these materials would be available in the description section. From there you can download and you can execute in your system. Okay, even this project implementation also I'm going to add inside my description section. From there you can watch that. So yes, guys, this is all about from this video. I hope you liked it. Thank you so much for watching this video, and I will see you next time.